Hello everybody, welcome back to the training of the Modicon M221. In this video, we're going to talk about the different timers that we have in EcoStruxure Machine Expert Basic. So let's go to the presentation. In this part, we can see the different timers that we have. We have three timers on the software: T on, T off, and TP. Here you can see the different types and how to add it. Basically, we have this icon for the function blocks, and this one with the clock is about the timers. In this part of the presentation, we're going to see the difference between the T on, T off, and TP, but in all of them, we need to define a period of time, and after that period of time, the output basically will be activated, but based on the timer, we have different behaviors. So let's continue with this. Once we added the timer in our function, which is in our code, if we move the mouse over the function block, we can see here a pre-configuration where we can select the timer that we want, T on, T off, and TP, and then the base time. Based on the configuration that we have on the preset, it will multiply by the time base that we have. If the preset is 3 and the time base is min in minutes, the preset will be 3 minutes. Okay. Now, if we double click on the timer, we can see the timer properties for all the timers that we have in the software. And if we want to access to these timer properties without double click on the timer itself, we just need to go to Tools and select Software Objects and then Timers. Now, if we all these timers, okay, are linking to an instance that start %tm. So each instance of the timer has a number. So if I add the first timer will be the %tm0, okay, and in this instance we have different variables that inside this instance of the timer. As you can see here in this part, we have for the output, if we want to use the output of the function block in another part of the code, we just need to use the %tm, the number of the timer that we have, and then .q for output. If we want to change the preset, okay, because by default we can configure the preset, okay, but if we want to use, for example, an HMI connection and make the modification of the preset, we can link the preset value to a %NWU variable. So we can change remotely using the %NWU that we're going to be in HMI, for example, and then move the value to the preset. And if you want to see the actual value of the time, what we can do is to move the value to a %NWU so we can see outside the PLC, for example in an HMI, the actual value of the timer. And we can also make the comparison for the actual value. So basically in this part, I explained to you that when we have a timer, okay, the block has some variables linked to that instance of the timer that allowed us to make some modifications. For example, the preset. So we can use an HMI to change the value. We can use an HMI, a Harmony HMI, or um, the graphic display for the Modicon M221 to change the timer. But we must link that preset value, okay, to a %NW, so we can change remotely that value. And we can also share the actual value of the timer to the HMI or to another device that we want. Let's continue this. And in here, we can see the difference behavior for the different timers. And this is very important. So as you can see here that we have int, the timer, it doesn't matter the number, .p, the value of the timer, the actual value of the timer, and the output. So in the timer on delay, when the input is 1, okay, the value of the timer start rising until it reach the preset. So when the value of the timer reach the preset, the output will be activated. Okay, so here it makes sense why it's delay output, because um, we activate the input of the function block, and after a period of time that we have defined on the preset, it will activate the output, and it remains in true in ones until we disable the input, as you can see in here. Okay, so it's working fine. And in this case, I have a start with the input, but the value, okay, the actual value of the preset never reached the preset, so the output is not activated. Now, let's start with the timer off, T-off. So the T-off works differently. We also have the input, the preset, the value, and the output, but when the input is activated, okay, the output will be automatically activated. So the input and the output will be activated, okay. When you activate the output will be automatically be activated. Then when the input goes from true to 0, the value start rising. So the timer will start increasing the internal value, okay, until it reaches the preset. So when the input goes from 1 to 0, it will activate the counter, the internal counter of the timer, okay, you can see here, until it reach the preset. So all this time from this actual value to reach the preset, the output will be in 1 until it reaches the preset, and then it goes to 0, the output. So we have this delay in order to deactivate the output that we have. So this T off is different compared to the T on. So the T off, when you activate the input of this timer, it will activate the output of the timer, and the preset or the timer will be operating when the input goes to 0, and then when the internal value of the timer reaches the preset, the output will be in 0. And in here you can see this example. Okay, so in this case the input is activated, okay, and in this case, okay, you can see that the output is activated also. But in this case, the input goes to 0, the output stays in 1, the value of the internal timer for the preset never reach, okay, so this one, the Q is in 1, and in here I activated the input once again, and the preset, the internal value, start counting again. Okay, just to bear in mind this part. And the latest one is the TP, that basically when we activate the input, as you can see, the output will be activated, but the duration from the output to be in true will depend on the value that we have configured on the value on the preset. So when the input is activated, the output is also activated. You can see the internal value of the timer start rising until it reaches the preset. And when it reaches the preset, the output will go to 1 to 0, okay? And it doesn't matter the value of the input, because it just generates a pulse on the output, okay? And you can see here again, so it activates the output, and it doesn't matter if you activate again the input, it just only obey the first one until it reach the preset on this value. So here I'm put in 2 times the input, but it only cares about the first one until it finish. And then we have the retentive. So the retentive basically we don't have for the TP. We have for the T on and T off. Basically the retentive, we retain the value, the actual value, okay, when the input is disconnected, as you can see over here. Okay, this is basically the retentive for both of them. It retains the actual value of the timer. So now let's work in our application so we can understand how we can use the timers. But first, let me just show you this example. Here, timer, here this page, here. So this small application I have made, you can see here the timers, okay? I have this T on, okay? And when you move the mouse over here, you can see the pre-configuration. You can select the T on, T off, and so on. And in the latest version of Machine Expert, okay, there is this dynamic preset that I'm going to show you now how it works. So I'm going to simulate this. Launch simulator. Going to activate this. Okay, good. I have animation table for this. So I'm going to configure the timer, the preset for the timer, T on timer here, 5. You can see here I'm linking a percentage %NW0 to the preset, so we change the preset over here. And now what I'm going to do is to start this. You can see after 5 seconds, the output will be activated. Now, this dynamic present works differently. So imagine that I'm still working with the timer, okay? And let me just change this to 10 seconds. Okay, now I'm going to activate this and I'm going to change this value to 15. Okay, you can see here it activates to 10 because it was the previous value that I have. Okay, now if I turn off the timer and on again, instead of 1, it goes to 15. Okay, and the reason is that in order to activate the preset, the input should be in 0 and then starting on again. And the difference now in the latest version of the software, you can see 15 as it goes to 1. If we select dynamic, okay, let me just double check, dynamic, okay. So let's start again, 10. Okay, just show you that it goes to 10. Perfect. So now I'm going to activate again, but now in here I'm going to select 15. So now you can see that it's not going to be activated in 10, it will wait to 15 in order to activate. As you can see, now it goes. Okay, just to show you this part, the difference of the dynamic preset, which is a new feature that we have in the latest version of the software. Now, let's continue with the application that we were working with. So what I want to do now is to implement the T-on to activate an alarm. So if the output Q0.0 is activated for more than 5 seconds, we need to execute this alarm Q02. So what we need to do is to add into the in the PRG underscore MGMT that we already working with the timer. We need to replace the logic that we have before in order to add this timer. So let's go back to our project here in the other screen. So in here we already have this counter that we have already created to see the time that the motor is activated. So we are going to delete this part. Okay, now what I'm going to do is to select the timer here and put it over here. Okay, let me just double check if I name this in a different way. Timer motor on. So double click on this object, timer motor underscore on. We're gonna preset this for 5 and then time base 1 second. Apply. In this case, you can see that in this particular project that I have created before the latest version, it doesn't allow me the dynamic preset. And in order to solve this, what we need to do is to select behavior. Here, select the latest one, okay, and apply. You can see here the latest one support new timer preset mode. Apply. Okay, good. We have changed this. Let's continue with the part of the presentation. Okay, on 1 second. Now we need to go to the PRG of alarms that we have in order to replace the logic that we were using and use the output of the timer. So let's go back to our application. Just open this one. Yes. So, no, this one, no. Let me just select this, select the other application, my button there. This one. So we need to use the output of this timer to activate the alarm. You can easily use another variable, okay, and here select the percentage blah 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 that you want, but I'm going to make the things a little bit different so we can use the output directly of the block where we want to do it. So here I'm going to replace this. I'm going to add the contact here tm0.q because it's the timer on that we have selected the output. So it's the same this way that using a percentage %m, but I'm going to use directly the output. Now let's go back to the presentation to see if I'm missing something. Okay, so now if we want to, as I explained before, if we want to use a different preset, a dynamic preset that it can be changed, we need to link a percentage %m variable so we can override the preset that the timer has with a variable that we have. So in this case, we can imagine that we are going to use the TMH2GDB, which is the graphic display, or an HMI, to access to the percentage %NW of the PLC to change the preset. So this is what we're going to do. What we're going to do is to create a POU, PRG config. I'm going to create a new variable, the percentage %NW10, to access to the preset of the timer. So let's do that. Here. So let's create the variable first, MW10 if I'm not wrong, CFG underscore motor on, I don't remember the name, timer motor, okay, timer underscore motor. Good, I already created this variable. Now what I want to do is to create a PRG, a POU. I'm going to move all this down. Perfect. PRG config, the of configuration. Going to add the short because select to add the short at the beginning. And in here, what we need to do is to enter we can use the symbol or the address. I'm going to use the address, percentage %TM 0.p for preset colon equal percentage NW10, which is the variable that we have created. So in this way, we are changing the preset of the timer. Let's try to download this into the PLC. Let me just connect the USB first to the HMI to the PLC, since that I've been doing another test here and I have a different IP address. Just hold on a minute. Okay, it's connected over here. Let me just check the IP address here. It's one. Apply commissioning. Let me see. CMD. Just checking if it's a device that I want to connect with. 221. Perfect. So let's download here. No, I'm going to use this one. Download, login. PC to controller. So we can use the real PLC. Okay, good. Here you can see that the default value of the timer is 0, okay, because the initial value is 0. So if we want to connect an HMI, for example, let me just open the Operator Terminal Expert so I can show you how we can change this value remotely for the preset. If we go to the management, here you can see that the preset is in 0 after this start loading. Okay, so let's move this over here. Going to start a new project. This is just an example how to access remotely to the HMI to change a value, in this case the timers. There is no need for you to learn how to use the Operator Terminal Expert. It's the software that I have in order to show you. So let's go here. What I'm going to do is to simulate the HMI. So the first thing that I need to do is to add the driver. Schneider Electric. I'm going to use Modbus TCP. I'm going to select the name PLC underscore M221. Here the IP address of the PLC 1221. Okay, equipment address, this is correct. Syntax, base 0, low, low, perfect. This is the configuration in order to communicate the HMI. There is different ways in order to connect the Operator Terminal Expert to the M221 that I'm going to explain later. Now, what I'm going to do is to directly create the variables, but later you can see a faster way to import the variables from the Modicon M221 into the Operator Terminal Expert that we're going to see later. Here, all variables, just create one or CFG timer, for example. It's not going to be internal. Device address is going to be 10. Okay, and in here, let me just put the variable that we want to use. Numeric display. Here, variable 2 ways. Okay, so let's simulate. Hopefully, we should be able to change that variable. Okay, syncing is on the other side of the screen. Good, so this is the HMI, and if I change this value, for example, to 5 seconds, it should change the preset over here. If I change this to 10, 10, 5. And if I, let me see, if I, we have the outputs, aux M0. Just want to show you the behavior and the execution. Aux motor will activate the Q0, and we just need to go to percentage %tm0.p. This is the variable that we will be overwriting by the percentage %nwv10. Okay, and the alarms. So basically, I want to show you that it works. So this is how you can make the communications. Already tested with you. Let's change to 6. Now let's activate the output so you can see that the output is in there working, and then after 6, there we go. The variable for the alarm is activated. Okay, so this is basically how you can use the different alarms that we have in the software. Just change this view, and there we go. So we have seen the 3 types of timers, the 3 different types of timers that we saw. Okay, if we go back here, we have these 3 types of timers. We already seen how to implement the T-on timer, but as you can see here in the example, how you can use it is very simple. It's all the same. How you can uh, configure the timer is very simple. You have the possibility to use uh, um, a fixed preset, and if you want to change that value from outside, you can use linking a percentage %NW variable to the preset, as I show you in here. Just go back here. Timers guidance, as I show you in here. In the management, you can in the configuration here you can link the timer, the preset of the timer, with a variable, and this variable is the one that I use, for example, in my case in the operator terminal expert, to change that value. Okay, so this is it for the timers. Thank you very much for watching this video, and I see you on the next one.